All right, ladies and gentlemen, today we are discussing Topic 9, Lesson 3, which is all about rewriting radicals. Now, radicals are things like square roots or cubed roots, things like that. Today, because we're talking solely about quadratics, we're going to talk about square roots. Now, this is not an actual method right now that will help you find zeros of a quadratic equation. What this section is going to do is this is going to help you to communicate your answers in future sections. 9-4 and 9-6, I believe. No, 9-5 and 9-6 are all going to use this section. So this is a building block to help us better to communicate our answers in future sections. What I want you to make sure that you have in your notes on this left-hand side first is this kind of just review. Last year, if you took 8th grade math, this should have been something that you went over. I want you to have these perfect squares memorized. This is the easiest way for you to remember how to rewrite radicals is if you know these perfect squares. It's going to be way easier for you. So just knowing 1 squared is 1, 2 squared is 4, and so on, all the way up until 12. 12 squared is 144. Now, if you know up until 15, that would be even better. If you don't have them memorized, that's okay, but you will have to use this sheet quite often because you will be looking for perfect squares inside these radicals. I also want to just discuss, like last year, what you guys focused on was that finding the square root of 16, that's easy. It's a perfect square, that's 4. Finding the square root of 25, that's also easy because it's perfect, it's 5. Now, if you were finding the square root of 20, you last year were just estimating that. Well, 20 is between 16 and 25, so I know it's going to be somewhere between 4 and 5. Well, it's closer to 16 than it is to 25, so it might be like 4.4-ish. But we don't know exactly what it is, but that's what you would have done last year. This year, we're going to simplify this square root of 20 easier, or so, more specific, more exact than we did last year. Okay, so what I want you to do is we're going to write and talk about how to do that. And we're going to use the product property of square roots. Now, what this says is that the square root of a times b can be written as the square root of a times the square root of b. So we can break down whatever number this is into two different factors and rewrite it as the square root of those two things separated. Now, the a and b values have to be greater than or equal to 0. Now, we have to remember that we cannot take the square root of a negative number. So, going back to this example, the square root of 20. What we're trying to do is break 20 up into two different numbers so that we can simplify this. Now, this is where the perfect squares comes in handy. We want to try to break 20 up into something that is a perfect square, and then whatever's left over is not going to be a perfect square. So in this case, the perfect square that goes into 20 is 4. Okay? So 4 times 5 gets me to 20. But now I can simplify this because it's a perfect square. So the square root of 4 is 2. So the square root of 20 is actually written as exactly 2 times the square root of 5. Okay? So what we can do is look at different sets of radicals. To determine if they are equivalent to each other using this new skill. So the first one is the square root of 36 and 3 times the square root of 6. Now, can we simplify either of these, whether they're perfect squares or not perfect squares? If I look at the square root of 36, that is on my list of perfect squares. So I know that the square root of 36 is equal to 6. Now, the 3 times the square root of 6 cannot be broken down any further, because I cannot break the square root of 6 up into something that is perfect and something that is not, other than 1 and 6, because 1 is a perfect square. But that doesn't simplify it any further. So this is already simplified. So these are not equivalent to each other. However, 6 times the square root of 2 and the square root of 72 may be equivalent to each other. If I look at 6 times the square root of 2, I can't simplify that any further because 2 is not a perfect square and there is not a perfect square other than 1 that goes into it. However, the square root of 72 does have a perfect square that goes into it. I can simplify this because I know that 9 goes into 72. So I'm going to break that up into 9 times 8. Now 9 is a perfect square, so I can break that down further into 3 times the square root of 8. But I'm not done. You should be noticing that the square root of 8 can break down further. 8 can be rewritten as the square root of 4 times the square root of 2. And I can simplify the square root of 4 to 2. Now, if I have two numbers out front, I'm going to multiply those together to get 6 times the square root of 2. Now, if I look here, this simplifies to the same thing as the other one, so they are equivalent. Now, some of you might be thinking, well, wait, there's a bigger perfect square that goes into the square root of 72. You might notice that the square root of 72 actually could be broken down by the square root of 36 times the square root of 2, and seen that that answer, 6 squared root of 2, you could have arrived at it way faster. That is perfectly acceptable. It's similar to simplifying with fractions. You maybe notice something smaller first and have to do it a couple of times before, unless you notice something bigger and it goes into there quicker. So either method works. One's just a little bit faster than the other. Okay, back over to the left-hand side here for just a second. Now what we're going to do is we're going to start throwing variables in there. But what I wanted to make sure I pointed out to you is that when you take the square root of something like x squared, you get just x. When you take the square root of x to the 4th, that is x squared. Okay, so remember those exponent rules we learned about. This square root is actually 1/2, so we would multiply 4 times 1/2 to get 2. the square root of x to the 6th is x cubed. Okay, so it's important to know that even exponents are perfect squares. Where odd exponents are not, they're going to have something left over inside the radical. And then this one is the square root of 4x squared, so the square root of 4 is 2, the square root of x squared is x, so 2x. Okay, so I'm going to give you a few examples, and we're going to do a couple together, and then I'm going to leave you with one as a try it. So first, all we're going to do is we're going to practice simplifying these. So I'm going to have the square root of 63x to the 9th. Okay, so what I want you to think about, sorry you can't see that that's really a 9. What I want you to think about is what are the perfect squares that go into 63 and that go in x to the 9th, and what are the leftovers, or the things that are not perfect that go into there. So if I'm thinking about factors of 63 and my list of perfect squares, I know that 9 goes into 63, and 9 is a perfect square. And I know that when I multiply 9 by 7, I get 63. So my 9 is perfect, so I'm going to put it in this radical. My 7 is not perfect, so I'm going to leave it over here in this radical. Now, if I break down my x to the 9th power, I'm going to take all of the exponent, or all of the x's that make it even. So I'm going to take 8 of them, and I'm going to put 8 of them over here. And the one x that's left over, I'm going to leave over here with the 7. That's not perfect. Okay? Then I can take whatever's inside this radical, this perfect square root, and I'm going to break it down. The square root of 9 is 3. The square root of x to the 8th is x to the 4th. And my radical 7x stays. Just like that. Okay? Now, there are other times where you might have a number in front of your radical. Okay, so for the time being, we're really going to just ignore that number out front. So I'm going to ignore it. I'm just going to rewrite it down here. And then what I'm going to do is I'm going to rewrite this as everything that's perfect under one radical and everything that's not or left over under the other radical. So I have the number 4. Well, I recognize that 4 is a perfect square, so I'm going to put all of it there. And then I have x to the 17th power. So I'm going to take 16 of those x's and put them over here with the 4. And I'm going to leave the 1x by itself. Okay, I'm going to bring down my 5 again, still kind of ignoring it because I'm not ready for it yet. And then I'm going to take the square root of 4x to the 16th. Well, the square root of 4 is 2. And the square root of x to the 16th is x to the 8th power. And then what I'm left with is the square root of x. Now this 5 was being multiplied out front, so I'm just going to multiply it to that 2 to get 10x to the 8th square root of x. And that is your answer. Now I want you to try these two on your own, and then look back at my notes later to check.